University of California, San Diego, who is also known for pursuing high-risk, high-reward projects, taking chances and making a confident leap into the unknown. She is developing tools for quantitative cell biology and using a lot of cryo-EM. What I love about her is that she's so open to learning more new stuff and being fearless into diving into the unknown, as I said. And lastly, we also have Dr. Mara Dierssen, who is from CRG Barcelona. She works on trying to find out the mental codes behind neurodisorders, such as Down syndrome. She is not only an amazing scientist, a great speaker. Do join us for her talk later in the afternoon. And she's also been the head and president of a lot of societies, such as the Down syndrome societies. She can also give us a lot of information about how to lead not only a career in science, but also have administrative finesse. Our moderator for the session is our very own Professor Mary Osborn, who has helped us evolve this panel discussion into what it is today. Dr. Mary Osborn might be known to you for a technique that you might perhaps use every day if you're a biochemist. She was with her husband Klaus Deber, the one who developed SDS Page, probably something that we use every week in the lab if you're a biochemist. She's also known for stunning immunofluorescence images that help decipher what microfilaments, intermediate filaments, and microtubules are. And in addition to that, she's got loads of accolades and lots of achievements. She's also a very proud advocate for females in science and STEM fields. With these introductions, I'd like to introduce lastly our very own Newt Scamander and the topic of our panel discussion. We titled our panel discussion, Troubles of a Young Scientist, Fantastic Ideas and Where to Find Them. There's a little difference. Instead of a wand, he has a micropipette in his hand. Fantastic ideas, quite like fantastic beasts, are sometimes just too much of a fantasy. What is a fantastic idea? Is my idea actually a fantastic idea just to myself, to everyone? How to develop one? Once you have one, how to stick to it and let it sustain for a long time? These are all good questions, but not with a lot of answers. We're not sure if there are right answers to these. But today, we're open to discussions on these areas. It's also another thing about a fantastic idea, quite like a beast, it's difficult to tame them. Are your ideas too big to actually reach their logical fruition? Or do you need to be a little less ambitious, a little more realistic? All open questions, and we also invite open questions from all of you for this very interactive panel discussion. Thank you all speakers for joining us, and we look forward to a very insightful discussion.
Thank you, Nina, and thank you for drawing the poster. And thanks to all the members of the organizing committee of Horizons who had a much bigger input into the symposium than in previous years. So the questions you're going to see come from, in large part, but not exclusively, from them. Welcome to the panel. It's great that you come and not only give a talk, but that you will also agree to talk to the students. And let's get started. Good. This is a slide which was shown, for example, in the industry part. And basically what it shows is that for the science PhDs, your chances of making it out of it as a professor is very low. This is for England. It's for all disciplines. It's about 0.5%. But I want to cheer you up by saying, from my experience in the group I was associated with here, about 30% of people went and stayed in academia, about 30% went into industry, and about 30%, or the rest of them, went into alternative careers. So if you maximize, and if you take allowance for getting your PhD at an excellent institution, for example, like this institute, your chances of staying in academia, I think, are much higher than implied by this slide. But it's still true that a lot of you are not going to be able to stay in academia and need to be thinking of a plan B. And one of the purposes of this symposium is to sort of cheer you up about not only about academia, but also about industry, that there are a lot of good alternatives out there. You just have to learn how to take advantage of them. Now, hence this slide, because when we started discussing what we should discuss here, I got the most negative list of possible points that I've ever seen in my life. And I nearly said, okay, we can't have a discussion based on this. But then we talked a bit and decided that we could come up with sort of common ground. But I wanted to start by saying what I think several of the speakers will emphasize, several of the panel members will emphasize today, that science is fun, it's hard work, but it's fun, and it can be intellectually challenging as well. I'm not going to read out everything on these slides, but I am going to encourage you to make an active decision, both for your career choice and for what kind of problem that you work on. And don't leave it till the day before or the day after you get your PhD, because that's too late to get into a good lab in academia, and it's too late to sign up for a training program, for example, in industry. So then we come to the dilemma that a lot of you face. You're told, for example, and Polly, I'm sorry to start with two quotations by Peter Medawar, but I think his advice to a young scientist sounds like it was better than some of his science. But you have to acknowledge that choosing a problem, starting to study it, is a venture into the unknown, hopefully with confidence, but one can't predict in advance is it going to work out for you. That's what you've got to find out for yourself. What is often held up as is this idea that when you can solve a problem, that you get a kick out of solving the problem. Lots of us do. It's very nice to solve something, and it's very nice to solve something first, not 10th. And that then you actually get hooked on doing science, choosing your own problem, and this sort of thing, or a certain fraction of graduate students do. And those are the people that will tend to stay in academia. You're also subject to a lot of other pressures. For example, you're told you must be a pioneer carving out a niche for yourself that is unique and where you will be at the top of the heap. Well, it's easy to say, it's not so easy to do. And just to stress something from the book and the website, 80,000 hours, which is the time, it's actually less than the time you will spend on a scientific career, because 40 hours a week is probably a little too little. But the choice of career is terribly important, because that's what you're going to be doing. And you might as well also spend some time choosing something that makes you feel good, and which you like, and where you have fun. Now, and notice the sentence, but for such an important decision, there's surprisingly little good advice out there. That's true. You sort of make this plunge into the unknown, and then you sort of are left often to fend for yourself. So, what did the Horizons team come up with? They came up with this citation, which is also in the booklet. And you can see that accounts for the troubles of a young scientist part of the title. It's not so easy, because you're finding your way in a new field. The trajectory, I agree with, is not a straight line. And so you have to figure out for yourself whether the rewarding times sort of compensate for the times when your experiment isn't working in the lab, all right? And figure out ways out. And so, you know, the questions that are raised is, am I asking the right question? Am I answering it in the right way? And what does right mean? And that's what we're going to ask the panel in a minute. Now, this is the kind of things that we're going to try and discuss in the next time. And at the end, we will open it up for 15 minutes to questions and comments from the audience, because you probably have some pressing questions, and you should take advantage of the panel that we've got here. So, let's start with the idea, which is what we want to emphasize, how to find something worth pursuing, how to find a problem you want to work on, and something that will create an impact and is sustainable. And I'm going to do that by asking each of the panel members why they chose the problem they're working on, and why it's a fantastic idea. Next.
Oh.
Polly, you said you got some of your good ideas in the
sexism?
bath. But you know the other person who has gone on record.
I'm sorry?
You know the other person who has gone on record as having good ideas in the bath?
Our
And
comedian.
that's Fred Sanger, who
No.
got 2 Nobel Prizes, and he put it in writing.
That he had him in the bath?
He said he got his best ideas in the bath.
Yes. Nobody's asked me to write that kind of essay yet. Okay, so how do you find a good idea? How do you find an idea? I say read. No, seriously. Most PhD students don't read enough. You don't read until it's time to start writing. And then you discover that there's all kinds of stuff out there that would have made your work much easier, or that there's stuff out there that you redid when you didn't have to, or there's stuff out there that could have led you slightly sideways to something more interesting. Right? Now, this is advice not only to students, it's also advice to their supervisors, because a lot of supervisors want you at the bench, right? So when we still had to go to the library, I would force people to go to the library and spend an entire day, 1 day a week in the library. Read. Start reading now for your thesis, because it's too late once you've done all your experiments and you start writing. When you read, you will find questions. You're reading a paper and you'll say, how do they know that? Right? If there's a reference at the end, go read that reference right then and there. Don't wait until you finish the paper. As soon as you have a question, go find that reference. You're going to track back several papers when you do that, because you'll read the second paper, and halfway through the introduction, you'll say to yourself, how do they know that? Or what was the experiment? Right? Stop. Go find that reference. Read. If you read this way, it's difficult in the beginning because you're reading all kinds of papers that you don't understand the terminology, whatever. You will get an incredibly broad knowledge. And you'll start seeing questions that come up. Right? Oh, the textbooks say this. That doesn't make sense. Remember I said this earlier? If it doesn't make evolutionary sense, it's kind of dumb. By reading, you will find questions that interest you. And when you find a question that interests you, those are the ones you want to follow. Not necessarily some other question that may be a grander question, but it doesn't interest you. Right? We all know now, by the time you finish your first or second year of a PhD, that 90% of scientific research ends in failure. And that's when it's good. At its very best, you fail 90% of the time. You have to be committable. You have to be nuts to do this job. Right? You have to actually be drug addicts in a funny way. Right? That first real result, I remember my very first one, it was 2 in the morning. I went to the gamma counter, we were still using gamma counters, and there was this result that I had predicted, and it came out that way, and I was hooked. Right? And then it took another 4 years before I got that result again. So, if you want to get ideas, read. And question. And when your PhD supervisor says, what are you doing today? I'm reading.
Good. Yes, could you give it to Mara next?
Oh, okay.
So, we follow the rule now. Yeah, so this is a very interesting topic, because especially when you start, it's like you are simply following the ideas of others, right? Following the questions of others, not your own questions. And one of the things that you kind of are very insecure is, did I choose the right scientific problem? And what are the the drivers that I should follow to choose a problem. And I have very good colleagues, very smart people working on yawning, right, and the cross-species comparisons and things like that, which is interesting. Well, you could think, wow, is this really such important, or why should I pick this problem? So part of the things that have been said here are also, I share this opinion. So ideas do not come just by chance, no? You are there and suddenly, oh, I got an idea. No. You need material to think about it. And the material is the ideas of others. And one reason why I started doing neuroscience was because I suddenly realized that somehow some of my ideas were there already and people had explained them better than I did. And I was like, oh my. So why is that? Is it because we are hardwired in a similar way? Our brains are somehow similar so they can come to the same idea. And one thing that I realized was that normally ideas come better when you have this material, these kind of stones that you can build your idea upon, but then you share these ideas and discuss them with others. There is where you really get them. And then you don't get anything for days or months or years, and suddenly in the bath, because this is how the brain works, right? Everything is behind the scenes, and suddenly you're in the bath, and oh my goodness, that's it. So, and you go back to the lab, and you do the experiment, probably it will not work, but it will give you some more pieces to build a puzzle, right? And so it's really important that you do that. And to add some other advices, is that read, but then explain your ideas to others. And if it could be others that are not in your field, or to your grandma, okay? Explain it to people that do not understand anything, because this will clarify in your mind what you really are pursuing. So it's very important that you speak up your ideas. And now, I hate this, sorry, the industry, no, but I hate this state of the art that you cannot explain your ideas before publishing because others will step on them. Oh, come on. This will happen to you. I mean, I had many papers like not being published because somebody stepped on them before, right? But that's science. I mean, we have to share our knowledge because this is how science grows, right? And I agree that intellectual property and all these things are very important, but I'm a very basic scientist, so I really believe that knowledge comes out when we share it. Okay.
Elizabeth.
Good point. So we have seemingly a panel that agrees on everything, because I had prepared to say things that I've been told. So I'm just going to add, I think reading is super important. As Einstein said, inspiration will come, but it better find you working. And it doesn't mean in the bench. It really means that your brain has to be brewing all these ideas. You have to have the knowledge and the blogs, and that means reading and asking questions. And exactly like Mary says, like challenge the textbook. Just don't go, this thing that we all have social media now and we read diagonal, and that means we don't really read anything. So this really thoughtful reading process that you do all the time and sort of try to question things, and you do it all the time. When a speaker gives a talk, you find a way to ask a question. You don't have to ask the question, but you listen to the talk so that you're thinking about challenging or asking a question or getting an idea. How did he get here? How does he do that? And again, you don't have to ask it, but it's sort of, it's like you can stretch your sort of muscles of questioning and formulating ideas. And then be generous with your ideas. Most ideas suck. Just put them out there. I think most of you maybe know who Joachim Frank is. He just won the Nobel Prize last year. His son is way more famous than him. He runs BuzzFeed, I think. And he has this, he has this video that's called Brain Crack that I love, so just go Google Brain Crack. And that's what he says, like, you know, you have this idea, and then you fall in love with your idea, and in your head it's so perfect, your idea. So I actually don't like this concept of fantastic ideas, because I think most ideas kind of suck, and then you shape them into be, but when you get high on your idea, you put it in there, and in your mind it's perfect, and every time you're like upset, you go back to your idea, and I mean, honestly, that idea is gonna probably suck, and what you have to do is exactly what Ramona said, you just put it out there, Yamuna said, you put it out there, and then it sucks, and then you know the third or fourth iteration are probably gonna be okay, and you're gonna get information back from people that are gonna shape your idea into something beautiful, and if they take your idea and run with it, well, then, you know, it's flattering, right? So you had a good idea. Now you go for the next one, because there's never one idea. I think that the time where one idea makes or breaks your career is over. All the interesting, easy stuff is done. So it always has to be a process. I really encourage you to speak out your ideas out loud. That is a really good question. You know, help people polish them, and you know, be generous and give them credit for you know, being part of your idea. Be it your grandma or your dog or yourself in the mirror. You know, I think it's important to sort of like, you know, just share your ideas. Like, you know, takes a village to get an idea, right? A fantastic idea. So.
David, the last one here.
I actually put a dog on a paper.
That's great.
What?
Okay, it's a collaborator. So I'm going to start by agreeing with Elizabeth now, I guess. I do think it's important to communicate your ideas. So one of the things I've noticed a lot, though, so my career I've made in industry, I see PhDs, scientists come in, and they really struggle with that thing that I think most of us learn in school, that we always have to be right. And that really prevents us from sharing ideas and getting them out there and processing them, because we feel, well, I can't be wrong. I like to say a really important habit. If you were in my workshop, I gave 5 habits. This would be number 6, especially for PhDs. It's more important to be effective than smart. And it's a bit tongue-in-cheek, but the idea is if you keep hanging on to this habit of thinking you have to be right, you won't express ideas you have that are never going to be great right off. And even if maybe people laugh, or maybe you think, oh, that idea isn't so good, that's the way you find your way to something that does work. You know, industry, I think, has to operate that way, and people that are not scientists and business people tend to be far better at being wrong, because their attitude is, look, I need to figure out what won't work as fast as possible so I can finally get to what can, and they see it as this iterative process. And I think that's a lot of what we've talked about in processing ideas. I totally agree with writing ideas down. I put all kinds of things in my iPad. And in fact, I have one note that is called Found Today. And anytime I come up with something, I pull it out and I put it in that list. And every Monday morning, I have an alarm that says, review my list for the last week and process the things that look, you know, interesting. But that wandering around of things that might be great, they might be stupid, a month later they may look the opposite, that's really important. I don't think great ideas just, and all of a sudden you're there. Another quick thing I'll say, I'm really big on networking outside of your discipline, talking to people outside of your discipline, because a lot of innovation happens at the collision between 2 completely different things. As an example, so I'm a physicist and I worked in optics, lasers, photonics. In Boulder, Colorado, where I live, I've seen a lot of innovative companies grow up leveraging the photonics technology that is already very well developed and creating something new for bioscience. I've got a friend who started a company making for a particular assay that had to be done on a flow cytometer. He's got a little box this big that uses a CD player laser and a cell phone camera to make a really cheap assay for detecting HIV and co-infections, you know, that you can carry into remote cities in third world countries, if they're developing countries. Is really very cool. So, and you get that by talking to people in other disciplines like I'm doing here by sitting.
Good. Now, we're not going to ask each of the speakers about each of the topics, but we're going to have somebody who introduces the topic, and then anybody who has a pressing agreement or disagreement as a panel member should add on. So, the next...
Start by disagreeing with something you've already said.
Sure, as long as it's not too long.
No, it won't be long. It won't be long at all. So, we academics have a problem, which is that we really like being an academic. And to us, plan B is going into industry.
Yeah, can we
I disagree
perhaps
with
wait to discuss that till after David's presentation. But we'll come back to that point, all right? At the moment, I'd like to stick with the idea and to ask Elizabeth, how do you realize the potential of the idea? You have the idea, and how do you drive it to fruition, particularly with respect to making things work and collaborations, and a question from the students about, since you've just started your own lab, problems of authorship. When do you decide them?
Okay. I think, is this on? Okay, to realize the potential, I think you just have to, don't squeeze your idea too tight, right? So be flexible about the idea, approach it with love and from different angles, and then just work your butt off and read a lot, right? So I can't think of, making things work means try and try and try and try again. Try smart, fail fast. I can't stress this enough. Make the best pilot experiment to see if your idea is going to be bad, and then make the next best pilot experiment to see if the next step is bad. Because sometimes we really want things to work, and so we plan for step 84, but you already get the gut feeling at step 6 that maybe not, but you're now committed. But don't, so try to find ways to fail fast. So it's called this agile thing that they do in industry, that just sort of fail fast and move on, adapt, next thing. Collaborating is incredibly fun. I think it's one of the most exciting things in science, and I personally believe that you can't not collaborate anymore in science. The days of single author papers or even single PI papers are sort of over, and I think that's a great thing, but it's definitely complicated. My advice to you, which would be probably against the advice of 95% of people, is be very generous with your ideas. Don't get hung up if you end up being second co-first or something like that. Or I think that the time where one paper makes or breaks your career is also over, and it's a point of signal to noise is what matters. So I've had these problems, when I was a grad student, and at the time I thought, oh my God, this is so terrible and unfair, da, da, da. And it doesn't matter, right? At the end of the day, people look at the sum of all of your work. And also, at least in my experience, being generous has always given back at some point, right? So it comes back. And then so, people know that I'm flexible, then I give, and sometimes you get a lot back. And so, call it karma or whatever you want, but it works. And then, when it comes for authorships, I think that there's a way where things naturally evolve, and situations change, and I think the most important thing is to have very honest discussions as early as you can if you feel like this is a problem with people all the time, and then always tell people to be able to come back and talk. I don't know. I'm just starting. Sometimes it's very well defined. Sometimes it's not. Revisions of papers could even change things. A friend of mine told me, I've never actually found this study, but a friend of mine told me that someone made a study and asked people for their contribution to a paper, and that regardless of the length of author list, it tends to add up to 300%. And so, always, of course, your perceived, you feel like you contributed a lot, everybody does, and it can lead to problems, but, there should be a happy medium. And again, I think in this one, as in many other things, flexibility is important, so nothing should be set in stone. I think you should, when you think about your contribution or other people's contributions, if it takes them a day only, but it would have taken you 2 years, then it is an important contribution, and I think this is something that we forget. You're like, oh, but it took them 3 days to do that, and I've been working on this for 3 years. Okay, fine, but the paper wouldn't have gotten done without that, right? Or it takes them 3 days because they've worked for 20 years on making it so that it takes 3 days. And so, these are other things to contribute. Again, my advice for everyone is to be as generous as you can be and as positive. It seems that way. This is this paper is again, like being so strict. This is like, it all comes together. My entire life has been driving up to this moment. No, there comes another moment after that, right? And so chill. and work hard. I don't know what else to say. I think in my experience, putting your head down, working your butt off, and trying not to worry too much about those things has worked for me so far. Check back with me, but when I'm not tenured. But that would be my humble advice for that one.
Another thing, Elizabeth, that students wanted to know from you is how do you make your voice heard in a big lab? Because you were in a big lab as a postdoc, and then you moved and set up your own lab. But how do you establish your own profile in a big lab?
So I guess I'm naturally loud. But I think it's important to ask a lot of questions, ask stupid questions, be humble. You know, by these about asking stupid questions, I rain down on my students when I have a stupid question. I'm like, there's no stupid questions. There's a lot of stupid answers. There's not that many stupid questions. But, you know, ask questions. Again, being generous, I think, and highly collaborative was very good for me in the Baumeister lab. You know, how could I help? It sort of comes back, all kumbaya. And then don't be scared of talking to your advisors. I think this is especially true. I think in Germany, Max Planck directors seem larger. I mean, they are larger in life, and they're so busy and things like that. And when I joined the Baumeister lab, people told me he doesn't like seeing raw data. I was like, what? That can't be true. And so, you know, I came with my first like suit of tomograph, like, ooh, and he loved it. You know, of course he liked it. And then he started coming to my office, and people are like, why is he coming to your office? Like, why are you not summoned to the Olympus? You know? And it sort of works, and I think it's sort of, you just have to, you know, instead of talk about things that are fun for you and fun for them, right? So you know, reserve your bandwidth for the things that matter if you have little access to the person. And make it about the science and fun, you know, ask them questions that will tickle their brains, because then they will come back in 2 days and say, you know, I was thinking about that idea that you told me. And so that's I think, how you establish it. And then with other people in the lab, big labs are complicated, for sure. Also, again, you know, be generous, be humble, be helpful, you know, give back to the lab, and I mean, don't be arrogant or a jerk, and don't be, I mean, alpha or whatever. I mean, it might seem to work on the short term, but on the long term, you know, you're not really building anything that, like, people are not going to be supportive of you. And, you know, no person is an island. You know, with time, you always need help from people. You need to, build your networks. And grad school is actually really, I have fantastic collaborations that are starting right now with people that I went to grad school with. And they have their labs, and it's fun, and you become like family, and so culture your relationships is important for success.
Anyone want to comment on what Elizabeth has just said? Yeah, Mara.
No, I completely agree with you. Maybe I would add to that in a collaboration, it's very important that you don't just tell somebody to do something for your paper, but a real collaboration is sharing ideas. So it's not just telling, hey, do this, whatever, Boston blot for me, right? And I will put you in the paper. People don't like this. I mean, you like it when you really get the insight of what is the idea behind. And then you will find that people will bring even more ideas that will make the whole story much funnier for both sides, right? So I think this is also important.
Good.
So I have one more quick. If you find another lab that's doing the same thing you're doing, and it looks like they might publish before you, it happened to me twice. And I called them up. I said, hey, I hear you're doing this. We're doing it too, and here's all of our results. Right? Talk about generous, right? So I gave them my results first. So that happened to me twice. And one time it ended up with 3 papers back-to-back in Science. And the second time it ended up with 3 papers back-to-back in Nature. So you win. Right? You win when this is not a collaboration in a sense, because they were doing their own work and we were doing our own work, but we were sharing ideas. And in fact, the paper in Science originally went to Nature and they were all rejected. And we acted as each other's strictest referees, and we all went and did back and did more experiments, and they ended up in Science. So call them up. Call them up. We are all in this game together.
Good. Could you keep the microphone? Because I'd like to go on to reaping results. You've already sort of touched on that. Do you celebrate success in your lab when you get a Nature or a Science paper, or 3 Nature and 3 Science papers?
With the dog? Yeah. No, the dog ended up me not being able to publish in JM for 15 years until the editor died. At the Basel Institute, we celebrated everything.
Yeah.
Yeah? Birthdays, divorces, marriages, papers rejected, papers accepted. I mean, we celebrated all the time. In my lab, I celebrate, well, I kind of reward a good question. Mm-hmm. So I keep a case of champagne. And when somebody asks a really good question at a lab meeting, they'll find a bottle of champagne on their desk the next morning.
Good Lord.
With a little note.
How long does a case of champagne last?
It varies a lot.
Okay.
It varies a lot. We can have dry periods. Somebody makes a really good suggestion for somebody else's study, right? Somebody publishes a paper, whatever. It's something good, they get rewarded. And not only do they get rewarded by getting the champagne, they get rewarded by everybody else noticing that they got the bottle of champagne, yes. Meaning that was a really good idea or a really good suggestion or whatever. Especially suggestions for somebody else's work.
Yeah.
Yeah? Okay, we celebrate when we send a paper.
Yeah.
Because for us it's done. Right? And the reviews come back and they're often nasty and horrible and whatever, and you have to go through it. But the fun part is when you finished it and you send it.
Yes. So how do you know when it's time to move on or give up on a problem?
I'm really
when
bad.
Things stagnate.
This is not what you want to ask me.
Who would like to comment on that?
I'm not very good at it.
You're an industry.
Good. Yamuna.
So what I do is so when I get back reviewers' comments and things like this, what I usually do is I actually ask, is the quality of the work increasing, right? And as long as it's increasing, I'm happy to do these experiments and continue. But if I find that if I do all of the experiments and I mean, you can mentally see, right, a yes or no answer, right? And it's really not improving the quality of the paper, then I just say, let's move on. The other time, so there's the second time, maybe I said that I would not talk about this until the paper was published, but I might as well just talk about it, is to understand when the reviewer has actually lost objectivity, right? And so there was this paper we sent out to Nature Materials, and this was because the editor of Nature Materials said, this is really fantastic, we want this. So I was like, really, but we don't publish in your journal. So he's like, no, we have censor papers as well. So we sent this to him, and he sent this out. And one of the reviewers had, by the time he reached he said, how can you call this nanotechnology? If the editor sends out a paper like this saying that this is nanotechnology, then we have to change our very definition of nanotechnology, and Watson and Crick should be the pioneers of nanotechnology. By that time he's reached this, you realize that the person really has lost objectivity. And then you ask, even if you answer all of these questions and all of the comments that he or she has raised, that is not going to get this person to be objective enough to flip their opinion, right? And so I sat Maulik and Anjana down, and I said, look, this is the case. And we could sit and write all of our, but I really think that this is better fit for nature cell biology or something else, right? And then they understood that. And I did tell them that this is a wonderful example of how not to review, right? Because actually what you want to do is, so that's when I decide to sort of say, call it a day with pursuing and trying to convince a reviewer.
Good. I think now we're going to move on to academia versus industry. And we're very lucky to have David here because he gave this talk, which some of you heard on Monday. Interestingly, it attracted 50 people, and I was told by the organizers that many more had expressed interest. And I think it's important because as long as you're in academia, you will always hear that academia is better and industry is not so good. But I think you're going to hear from David that that industry has quite a lot to offer. So I've asked him to repeat a couple of things from the talk and to add a few comments, because I think it's important to realize that when you're doing a PhD, you get a very one-sided view of industry, basically because people in academia know very little, for the most part, about how it is in industry. So David, thank you for staying until now so that we could benefit from hearing what you have to say.
Well, thank you. So just kind of start to walk through some of that. I mean, certainly.
Yeah.
So
or just say what you want, and we've got these slides for you too.
Great. Well, so, the first comment, I know you started to comment on this too, is that I think many of us in science departments in particular can end up with getting this attitude that industry is plan B, right? I know I certainly did from my advisor, so I'm a physicist. I'm maybe I don't know anything about this biology everybody's been talking about. So, and I did, my research was very fundamental physics. And so when I decided in the last year of grad school to go to industry, I had no idea what I was going to do, where I was going to go. But bigger than that, because that's a solvable problem, was this attitude that I sensed from everybody, including my advisor, that, oh, you're going to go out in industry and play with nuts and bolts and not be a scientist anymore, She specifically said, look, if you want to get a postdoc and go that way, I've got contacts, I can really help you. If you want to go into industry, you're on your own because I don't know anything about it. But it was more than that, just the sense of, So a lot of what I do when I travel and speak is really carry a message that it's a very exciting, dynamic environment. I mean, I look at academic research and industry as just two very important elements of a symbiosis. Is that a good biological word here? Because industry without the continuing research would stagnate and would not go anywhere. And so it's really important to keep having that. And of course, then industry generates tools that feed back into research and help push research forward because it can do more. And so I think it's really important, critical for both sides to recognize the importance of the other. People tend not to migrate from one to the other all that often. But I also like talking about differences, and I guess that's the slide we have up here. So I try to summarize it I think there are 4 key differences between academia and industry. And of course, I'm generalizing a bit. Put too many nuances on a message, it's too complex to communicate. But in general, academia is about creating knowledge, whereas industry ultimately is about creating profit. Doesn't matter if you have an idea that will change the world, you need money to execute that. And so you have investors and they need money back. The other 3 really kind of fall from that. Academia is about a full understanding. Certainly when you're doing your PhD, you can study something until you really fully understand it and commit time to that. In industry, we have to focus on getting to results, and sometimes that means not getting the full understanding as long as we're confident that it will work and move forward to get the result. In academia, you tend to need to become an expert. I mean, the Nobel Prize is typically the pinnacle of an academic career, and it's really about somebody showing an expertise over a career in a certain field, whereas in industry, it's more about moving quickly, so that means you don't need to necessarily be the expert if you can find somebody that does. It's a type of collaboration, and I know in a way that happens in academia, but it's more, we get so trained often to have to be the expert. Too many scientists in industry will take time to study something feeling they need to learn it rather than go ask somebody for help, and so that's a big difference. And then finally, science in general is about proving something by collecting enough data that when you send your paper off to the reviewers, they will read through it and hopefully conclude, oh, yep, you've proven your point through data. I know that's a simplification, right? But in industry, because you have to move quickly, many times you don't have the time to get all the data to prove something's right. And in fact, many times the questions are far beyond just a technical question. You know, when you're selling a product, there are issues around suppliers and the market and the economy and what your customer needs. And so there's really, you don't have time to try and get to a right answer if there is even one. So you have to get used to making decisions without all the data you might like. Those are the big differences, I guess, that I like to think of. And I even say, I go further and I say, well, you know, really there are 3 different kinds of jobs that come out of this. The first is a job where it's understood what needs to be done, and you just need somebody to do that job. So the job is to do what somebody tells you to do, and these are typically hourly, to generalize, and so they're worth a certain amount of money. The next type of job is there's a right answer, but we need somebody smart and trained well to go figure it out and implement it. And this is fundamentally what science and engineering tend to be. We assume the universe has an answer, or there's a proper design rule or something, and you can get to that if you just look at the technical part. And so that's worth more money because it requires training and skill. But there's a third kind of a job where there is no right answer. At least not that we'll get in any reasonable amount of time, and maybe just no right answer at all. But we've got to decide what to do and move forward. And this is leadership. And that is the most challenging thing. It carries a lot more risk, but it also carries a lot more money. And so when I compare them, I put a lot more dollar signs. And so when designing our career, we need to think about what are we really aiming at. If you just want to stay in, you know, not that you won't ever have to make hard decisions, not to say that, but there's you can have a mentality staying purely technical and working on that deterministic science and engineering. But one of the biggest struggles I see a lot of technical people make, because we're so used to trying to prove something with data and doing analysis until we're confident, we really struggle to move to that third level where we have to make a decision without all the data we might like to have. Somebody's got to do it. And this is where I've seen a lot of industry managers get frustrated with their scientists because they can't make a call, make a decision, and move forward. And so I like to focus on that as an important difference.
But you made the point also that having made the decision, then if you're in this third category, you work to make sure that the decision was the correct one.
Yeah, that's a technique that I've used to get beyond that. I learned several years ago, if you're faced with a tough decision and you've got a couple of options, and you've eliminated the dumb ones, that's good. You got to do that much analysis. My technique is, if I don't know which way to go, pick a choice, just pick one, and then work to make that the right answer. And it reminds me of 2 important things. One is my ability to predict the future is actually not nearly as good as I'd like to believe it is. That's what we tend to think when we've got those, but if I just do enough analysis or I do the right thing, I'll come up with the right answer. But that's usually fooling ourselves, and we're wasting time and our careers doing that. But the other thing is, once you pick a path, there's actually, you learn there's a lot you can do to make that successful. Once you've decided and you get past all the worry of which is the right answer, you can get your whole team focused on making sure that actually works out.
Thank you. No comment on startups because that was all on Monday, but it's an option for your generation, whereas 20 years ago it was no option to say, I'll go and work for a startup, or I'll stay in academia and also make a startup. I don't know if it's possible to stay in industry and also make a startup.
Oh, and create a startup? Yeah, absolutely. That's more common now than ever, I think.
Right. Okay. I wanted to make one point, because I'm not sure that as students you understand that in academia in the last 10 years, certain discoveries can make an awful lot of money. This is the story, for example, with monoclonal antibodies in Cambridge, humanizing them, and the sort of sums that were realized. And what you should realize, and this was done in the LMB in Cambridge, what you should realize is the distribution of the income from patents and licenses, which for each institution and probably in each country is different. So you should know it for your own institution. In the Max Planck, which is very generous at the bottom here, 5% goes to the people who administer the patents, who make the connections to the industry, and the 95% is equally divided between the inventor, you, the institute where it was done, and the Max Planck in Munich. And if you contrast that to the situation in industry, because David was telling me yesterday that in industry, if you make a great invention, you get what? A medal or $1,000. So
Yeah, it depends on
you
the
may
company,
assume
but
you
no.
get much more in industry, but that's not true. You have the possibility in academia of having the fun of doing it, having somebody else make the connections to the industry, and still getting a considerable supplement to your income. But just to depress you a little more, the additional money you may get isn't going to make you any happier, at least according to this sort of study from social scientists. And look at the positive effect, which is when people were asked, were they happy yesterday, and where that peaked. Now, this is 2010. It peaked at about $55,000, so let's put it up to $70,000 now. But more money doesn't necessarily make you happier. Good. Now, we then move on to the list of topics, developing your own profile and making yourself visible. And here, basically, we have comments from Yamuna about defining yourself and how to describe yourself, and also from David about how to make the best out of what you may think is not a terrifically distinguished profile so far as a student. But those of you who went to his workshop on Monday will have seen how he managed to take 3 cases where you might think that it wasn't terrific and turn them into something that sounded absolutely fantastic, I thought. Okay, Mona, you begin.
So, yeah. So without knowing that I had to develop my own profile, right, I did it. And the way I did it, the motivations were completely different. One was, I hated my PhD advisor, and so I said, I never want to work on what that guy is working on. The second was that, and you'll find this as a chemist, that you are constantly evolving, right? And if you are one of the better people, what you will be 5 years from now is very different from what you were when you started. Your ideas will evolve. Everything will evolve. You'll find, if you look back, you'll say, oh, I can't believe I was doing that uncool science. So I feel like really scared when I go back and see my PhD papers. I'm like, oh, I don't want to do this anymore, right? Yes, yeah, which means that you have evolved, right? So you should really be changing anyway, because that's the part of you that's naturally evolving. The second was my postdoc advisor is a fantastic guy. You know, it's like night and day. Anyway, so and what I learned from him was, I didn't want to do stuff which he was planning to do because I knew all of the ideas in his lab and everything, right? And so I told Shankar. Shankar, I love you to bits, but I never want to touch a quadruplex again. I hate the look of it, right? And so, and that was also because my own ideas were evolving, and rapidly I found that what I was doing was uncool, right? So I wanted to do something else, and so that was how I started doing something completely different, which was live imaging inside cells, which I spoke about. And so when I told Shankar, I really love you, but I don't want to do anything to do. Don't want to have anything to do with quadruplexes. He gave me a big hug. It was okay that time. He gave me a big hug and said, go and do what you want to do. This is the best news that I have heard. This is very important for you to not work on what I'm working because otherwise you will be under some kind of of the shade of a banyan tree. You'll never come out, right? So I didn't realize all of that, but it so happened. That's how I feel that anybody who is really a fast evolving scientist will naturally distinguish yourself from what you've done in your PhD and what you've done in your postdoc.
So how do you describe yourself now? I thought that was great.
Yes. So, over time you'll find how your own lab will evolve, okay? And it's not so much, it's a lot about finding out about what you are, really. And as Paulo Coelho put it, it's not so much about, I think I'm misquoting maybe, it's not really about finding out who you are, but rather getting rid of whatever is not really you, right? And so that, I think, is the real, so today, if I ask myself, DNA, everyone thinks that we are a DNA nanotech lab. No, even I used to think I was a DNA nanotech lab, right? But actually what we are is, we are doing quantitative chemical imaging. And using that, we're trying to look at the cell from a chemical perspective and seeing organelles, and trying to understand the chemical composition of organelles and how that drives organelle function. And tomorrow, so you are not a technology. This is the one thing that you have to understand. You are not a technology. So tomorrow there will be a better way of doing quantitative chemical imaging, right? And if I'm a DNA nanotechnologist, does this mean I'm out of a job? No, right? It's about getting the best platform that can enable quantitative chemical imaging. And so you will find that it will take time even for you, because your brain also has to catch up with what you're doing. But this is what I feel is really important, to find out what is it that you really are interested in when you are, say, looking at a cell or looking at a protein structure or a complex.
And to find a broad enough definition, which I think is the point that David will also make.
Can I echo that? What? Echo that. So if you're not interested, it's going to be a miserable life. Right? We fail 90% of the time when it's good. I once failed for 3.5 years of a postdoc in Cambridge, trying to do many different things. It turned out that there was a mix-up in the mouse colony. It took me 3.5 years to figure that out. Yeah? So that's when it's bad. But when it's good, most of the time you fail. So if you're not really interested in it, don't do it. You're going to quit. Right? We're not in this job because we make so much money. We're not in this job because we get so much fame. Right? And the fame, by the way, is fleeting. If you don't keep working, the respect disappears like that. Right? We do it because it's fun. If it's not fun, do something else. If it's not fun, find another question. Right? If it's not fun, find another lab. Right? We do this because it's fun, because we're curious, because we are actually developmentally retarded. No, I mean that. You know how little kids ask lots and lots of questions, and then we become adults, and we stop asking lots of questions? How does the toaster know when to pop up the toast? Right? Some of us are developmentally retarded. We never get into that adult state of stopping asking questions, and we also keep a lot of other childish qualities. You know, the absent-minded professor is not a fairy tale. We're developmentally retarded, just face it. And because of that, if you're not curious about what you're working on, don't do it.
Yeah, I would echo that from an industry standpoint too. Where of course you have lots of different options of companies and roles even where you can work. I always guide people to start with your strengths, but then define a target. What is it you want to do, and where do you want to go, and be honest with yourself about what you would enjoy and what you wouldn't. And you learn more as you get out there and do things. You learn more about what you like and what you don't. And I think it's important to go after that. Focus more on your strengths, not trying to fix all your weaknesses. That's really important. And don't get stuck in doing something somebody else tells you ought to be doing, whether it's your parents or your boss or whatever. Getting in touch with what you like and what you're also good at is really, really important.
And what you can persuade somebody else to pay for.
Yeah, and then that's, of course, in a company, somebody has to be able to pay for it. So that is important. You can't just say, well, I like, I don't know, kittens or something. I mean,
But how about, sorry, Elizabeth.
Yeah.
And when people tell you to, lean into your strengths and these kinds of things, and it should be fun, and sometimes you feel like this is a naive sort of quintessential thing that, oh yeah, like it should be fun. No. If it's not fun, and if you're not playing to your strengths, you're just not going to be the best, period, right? So if you think something is super cool science and you're miserable doing it, you basically are gonna lose to the person who actually enjoys doing that particular thing. So you have to